Try your luck searching on a topic in Google, and it would often be the case that you will get overwhelmed with the search results. Kubernetes networking topic is no different. It is one topic which is often misunderstood and many gets overwhelmed. The main reason contributing to this situation is the lack of proper conceptual information which could explain the topic from the ground up and not just brushing on the surface. This motivated me to make an attempt to explain this topic right from the fundamentals. Because of the vastness of this topic, I am breaking it to multiple episodes where in each episode I will make an attempt to explain a specific topic around this thing with an intention that someone finds this useful in one or the other way. Hello, I am Sanjit and welcome to my channel. In today's episode of Demystifying Kubernetes Networking, we will talk about an important topic which constitutes the foundation of Kubernetes networking, the Linux network namespace. But before that, what is a namespace? Let's try to understand it through an analogy of a school. Each classroom in the school are built in a way that they are isolated from one another. Such isolations helps providing privacy to teachers and students. Folks inside the classroom can only see others who are in the same room. They cannot see what's happening in another classroom. The classroom in the school is an analogy of namespace. Similar to a classroom, the namespaces in a Linux server enables service isolation. On a Linux server where there are many different running services, isolating each service from the other service brings huge benefits. Smaller blast radius for changes, smaller footprint for security related concerns, and many more. The Linux kernel provides 6 types of namespaces. Out of it, network namespace is one. It provides a brand new network stack for all the processes within the namespace. That includes network interfaces, routing tables, and IP table rules. You can think of network namespaces as taking the physical network interface and slicing it into smaller independent parts. Each of this part can be configured separately and with its own networking rules and resources. In Linux, one can create and list such network namespaces using ipnettns command and later use the ipnettns command to view the available network namespaces in the machine. With this introduction to Linux network namespace, let's now try to understand its relevance in context of Kubernetes. When one creates a pod in Kubernetes, first the pod gets assigned to a node. Next, just before the pod is deployed and container created, the container runtime creates the network namespace. Instead of running ipnettns and creating the network namespace manually, the container's runtime does this automatically. Next, the container network interface, the CNI, will assign an IP address to the pod and will attach the containers in the pod to rest of the network. If the pod contains multiple containers, both the containers are put in the same namespace and assigned the pod IP. This exactly is the reason why containers inside a pod are able to communicate with each other through loopback addresses. In summary, it's the Linux network namespace that gives Kubernetes pods the needed network isolations and at the same time enables the containers inside a pod to be able to talk with each other. Okay, that's me for this episode of Demystifying Kubernetes Networking series. In the next episode, we will learn about a critical container which is often hidden out of our sight but plays a very critical role in binding the Linux network namespace which we discussed in this episode. Thank you for watching, and I hope you liked the video as much as I did while making it.